Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, Lewis in the Western, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, Lewis in the Western.
An invention differs from an engineering project. Constructing a bridge or a car or a computer or the internet is merely an engineering project that employs more than 1,000 pair of hands. But faster computers and the fastest supercomputers could not be manufactured without the invention of the technological knowledge of faster computers. I'm not the technician that unpacked the crates of the new supercomputer. I'm not the technician that installed the internal computational components of the new supercomputer. Nor am I the technician that installed the internal networking components of the new supercomputer. And I'm not the technician that hooked those components into the cooling and power infrastructures for the new supercomputer. However, I'm called the father of the new supercomputer because I experimentally discovered how and why the technology of massively parallel processing across a new internet makes the new supercomputer fastest. Parallel processing was ridiculed, mocked, and rejected by Gene Amdahl and Seymour Cray, the two pioneers of the old sequential processing supercomputer and the old vector processing supercomputer, respectively. I was ridiculed, mocked, and disparaged as the bushfowl that crowed in the language of another village. Parallel processing was only accepted after decades of protracted and strenuous conflicts against the likes of Gene Amdahl, the supercomputer boss at IBM Corporation, and Seymour Cray, who designed 7 in 10 vector processing supercomputers sold in the 1980s. At 8:15 in the morning of Tuesday, the 4th of July, 1989, the U.S. Independence Day, in Los Alamos, New Mexico, United States, I made the first experimental measurement of the world's fastest computation ever recorded across an ensemble of processors that is a new internet. That experimental discovery represents a new way of looking at the computer. To be the first is a greater achievement than to be number one or to be the fastest. There is only one first, but there will be many fastest. I was the first to discover that parallel processing across an ensemble of the slowest processors is faster than sequentially processing only on the fastest processor or only on the fastest supercomputer. It was my most pleasurable experience to be the first person ever to stand at the farthest frontier of human knowledge and invent the massively parallel processing supercomputer that is the precursor to the modern computer. On the night of the 4th of July 1989, I had a powerful, unsettling dream. I woke up with the visceral feeling that I had permanently entered into the history books and into school reports. In 1989, I won the top award in the field of supercomputing, and it made the news headlines that a lone wolf African supercomputer genius in the United States has brought that figment of the imagination called parallel processing and brought the supercomputer technology from dream to reality. Today, the parallel processing supercomputer is in the history book and is the reason the 12-year-old is writing her school report on the life of Philip Emeagwali and his contributions to the development of the computer. I invented how to solve the grand challenge problem of supercomputing that had cast its ominous shadow over the first 43 years of the invention of the programmable supercomputer that was invented back in 1946. That invention represents a new paradigm in the history of the computer. The invention was the tipping point that led to the complete acceptance of the massively parallel processing supercomputer. That invention of the technology of massively parallel processing was immediately embodied into all modern supercomputers and is now universally used within most modern computers. That invention was the new knowledge that convinced the naysayers to change the way they looked at the modern supercomputer.
Insightful and brilliant lecture.